Welcome to Coding Problems Part 2. This video will include 5 problems to solve, and the topic for the problems are control flow. So what is control flow? Control flow is basically like the approach when we have a source file like this one over here. Basically it's read from top to bottom, but what control flow does is different to the original sequence. It breaks up the flow of execution and employs decision making like if-else statements, and then looping, what we are very common of, and also branching out code. So that's basically control flow, and that's what we're going to be dealing with. So let's get the first problem started. The first problem is called in range. Requirements for this problem is that we have to create a function that will accept 3 parameters. The first parameter is the number that we are testing. The second parameter is the lower bound, and the third parameter is the upper bound of our range. We have to test a number that falls within a certain range, and the range we're going to be providing by the lower bound and the upper bound. The following steps are going to be done to show how this is solved. So first of all, let's create a function here. So above here, I'm going to use C++ for this example, and what we're going to do is we're going to have a return type. Now what happens here is that it would return true if that number that is provided in the first parameter is within that upper lower bound range. That would return true, and if it's not, it would return false. It's pretty simple. So what we're going to do is we're going to have a boolean as the return type, and once we have that boolean as a return type, now what we have to do is we have to name the function. So we're going to name our function in_range, and inside of this we're going to have our numbers. So the first number, which is inside of this, will be called num, so the number that we're trying to test. Then we have the lower, which is the lower bound, and the upper, which is the upper bound. This is going to be specified, and now what we're going to have is inside of our implementation what we have to do. Now the question here is that if the number lies between the lower and upper bound, we have to return true, and if it doesn't, we have to return false. So it's pretty much a simple if statement here. What we're going to do here is we could say if, and inside the if statement we could have number is greater than equal to lower, so LOWER, and, so let's have the and then we say num, so NUM, is less than equal to the upper bound. So it means that it's greater than or equal to the lower, and it's less than equal to the upper. And then we could just have, basically we don't even need to have those squiggly brackets, because we could have just one line, and we just have that return true. So we could have that return true. So once we have that return true, we're done with the code. And if this doesn't run, we can just return false here. So we don't even have to have these squiggly brackets defined, pretty much it. Let's test this code over here. Okay, in_range, and I'm going to provide a number. Suppose we have a number, let's say 10, and the number that is the lower is 10, and the number that is upper is 10. Now what this has to print out is true. The reason why it has to print out true is that this number 10 lies between the range 10 and 10, because it's less than or greater than. So pretty much makes sense over here. What we're gonna do here is let's just console it output this thing. So G++ in_range, and we're gonna run the code. So now we have some issues here. First, it says that lower was not declared in the scope and upper was not declared in the scope. G++, and we have in_range, and let's compile it. It's compiled, now let's run it. Okay, you got 1 as the output. Now by default, C++ gives 1 for true and 0 for false. We could change that as well using another header file. Here we have to include input-output manipulation. And once we include this input-output manipulation, we could use one really important function we have here is called the bool alpha. So over here we could have boolean alpha, and right after that we could have this in range. If it's returning 1, 0 as true or false, now it's going to return true with TRUE and false with FALSE. So let's run this code once again. So compile and then run, and now you can see that there's true. Pretty cool. Okay, that was it with this problem. Alright, so the second problem we have is called the same name problem. Here what we have to do is check between 2 different names and determine if they are equal. If they are equal, then we're going to basically return true. If they're not, we're going to return false. Pretty much similar to what we did before, but now the data types are different and some of the implementation will be slightly different from the first problem. So let's get it started. So first of all, what we have to do is we're going to have to return Boolean false or true. So we're going to have a return of bool. And then we can have the name. So the name of this function will call same name. So same underscore name. And it will have two parameters. One is going to be the string, and let's say it's your name. And the second one is string, and then we'll say my name. Now, what we have to do here is that check if these two strings are equal. If they are, we're going to return true. If they're not, we're going to return false. So basically a control flow like your name, so Y-O-U-R underscore name. Pretty easy. So your name equals, double equal for equaling, and checking if they're equal. So my name. Your name equals to my name. We're going to return true. And then or if that's not true, we're going to return false. So let's just return false here. And now let's run this code. Same name. And we could have a, let's say, Sally. And this one is Sally. Should return true. Okay, so if this is Sally, and Sally should have a console output here. So, and also I want that bool alpha. So bool alpha, ALPHA, stream, and we're gonna have this over here. Hash include input output manipulation. And now let's run the code here. Over here we're gonna have, it's not range anymore, but we're gonna have to compile it. And now let's see if this is the output here. Okay, we have it true. CLS it. Let's test it for another problem here. Let's see. Let's say we have your name as Billy. And now we're gonna have to run the code again. So let's see. So compiling. Actually, this was not it. So let me just have to CLS this. And now let's compile the code. And now run the code. And now you can see that's false. That was a piece of cake. If you have any other solution to this, then please let me know in the comment sections. Problem number 3, always false. So the situation here is that we're trying to create a contradiction. And what a contradiction means in programming is that once you have a program and you give some kind of value, no matter what you give in, you will always get a false and you would never get a true. So how do we create some kind of contradiction scenario? We're going to have to create a contradiction scenario here, and we have some constraints to follow. First of all, it has to be a function which accepts a simple parameter which is called num. All right, it has to accept a num. Then after that, we have to use a combination of less than, greater than, or any of those logical operators to create a contradiction in an if-else statement. If the condition is true, it would equate to true. Otherwise, it would equate to false. The trick here is that it would never equate to true since you're creating a condition that would never become true. So let's start in Python. Here, what I'm going to have to create is a define function. Here, this is how we create a function in Python. So what the function is the name. What we need is basically the name for this is called always. So always underscore false. And we're going to have some input parameter. So I'm going to have the parentheses. And you're going to see that there's a lot of similarities here. But we're going to have some indents that will be a little different compared with C++. Here we're going to have some num inside of it. And now we're going to have an indent. Now this means that we're going to be inside of our function. So what we have to do here is apply that condition. Now we could say something like if num equals to empty, something like that. And then we could say return true. And over here we could say else colon return false with a capital F. Okay, so that's basically what our function here. To run this, we could say always underscore false, and we could just put a number in here. So let's say, let's just put anything we want. Let's say 10. And what's gonna happen here? So let's just run the code here. So run Python in file. Over here we could have one thing here. We have to have a print statement. So or we're gonna have a print function. So the print function has to have this, and now we'll print. So let's just run the code again, run it, and there you go. We got false, means it's false, even with 10. Let's give 100, and let's see if that equates to true. But it won't, it would give false. Now, this is one approach to solve this problem. Now, we could have another condition that would never specify and it would never meet. So what condition could that be? So we could have something like this. So for instance, we could say if num is, for instance, if we say num is greater than 0, and we could say num is less than 0. And this condition could never be true as well, because you can't have something greater than 0 and something less than 0 at the same time. So this will always equate to false as well, even when we have a number something like some common number like 1. And when we have this run, we're gonna have that false as well. Pretty cool. Problem number 4. So this problem is called movie review. Here we have to create a function to help us rate movies. What our function will do is split the ratings into different ranges and tell the user how the movie was based on the movie's rating. So let's follow the following steps. Here we have to define our function to accept a single number called rating. Then if the rating is equal to or less than 5, return void at all costs. If the rating was less than 9, return this one was fun. And if neither of the if statement conditions were met, return outstanding. Here we just have to define a function, and we could call this as movie review. So movie review. And we can have some input parameters here. Rating as our input parameter, because that's the number. Now over here it says if the rating is equal to or less than 5, return avoid at all costs. So let's adopt some control flow here. Here we're gonna have if the movie rating, so we could say rating, the movie rating is less than equal to 5. What we return here is avoid at all costs. So avoid at all costs, an exclamation mark. We're gonna have here else if. So what we could write here in Python, we could write else if, and we could have the inside parentheses added as well. So we could say if the rating is in between 5, so if it's greater than 5, so we could say if greater than 5, and this means that double ampersand. So if it's greater than 5 and is less than 9, so we say rating less than 9, then we could have a colon here, and we could say return this one was fun. This one was fun. And then we're going to have the last condition when none of them are, because if none of them are met, we're going to have the return, and we're going to have the string outstanding. And now let's just return and run our code. Here we're going to have pretty much, we're going to have to invoke this function if movie review, and let's give a review of our movie. So suppose we have a review of, let's say, 6. So if I have a review of 6, now I have to print this out as well. So print, and let's print from here, and now let's just run the code. So if I go here and run, and you can see this one was fun. So let's see if this was correct. Actually it was, because it's 6, right? So it's in between the 5 and 9, so this one was fun actually. Now if I have something else, for instance, if I have something like 9, now if I run the code, we have outstanding. Wow. So yeah, we basically got that, and it's pretty easy. Okay, so one other way to do this was have this less than equal to 5 here, but one thing what we could do is instead of having these two, which is a little lengthy, we could have just had it less than 9. And so if it was less than 9, because this condition was not going to be true if it reached here. So if this was reached, it was going to be in between that 6 and 9, which was greater than 6 and less than 9, and it would return the same thing. And then we could have just return the last one, which is return outstanding if none of them were true. And also, to make it more simpler, we don't even need this else, and we could just have this over here return, because it would just return something like that. So this is a much more simpler, condensed form of the code. Cool. Alright, the final problem for this video will be called max number. It's very traditional, very common here, and very simple. What we have to do is that we have a function with 3 parameters, and there are 3 numbers. And what we have to do is we have to find the largest among all 3 numbers. And if 2 of them are equal, we're going to have to return out something like it's a tie or something. So let's just get this started with C++. So what I'm gonna do here, I'm gonna basically have a return type of void. And I'm gonna call this as max num. And for this we have input parameters num1, num2, and num3. And inside of this, we're gonna have to test the thing out. So over here we have if number one is greater than number 2. If that's the case, what we could do here is put this, and we could say if num1 is greater than num3, the ultimate test. If that is true, we're gonna return the number. So we're gonna return num1. So if this condition was not true, we could have something called an else if. And we could say num2 greater than num1. And then inside of it, we could say if. So it's a sub if. So if we say num2 greater than num3, and then we could say return true. Okay, return num2. And the last condition here we have is else if again. Else if num3 is greater than num1. If num3 is greater than num2, return num3. So if num1 is if it's greater, then it's going to return 3. Okay, if somehow none of them, or maybe two numbers are equal, or maybe all of them are equal, we could just have else. And what we could have it defined here is we could just have, instead of returning something, we could have it just consoling output. So let's just prompt it in our terminal screen. So we could just have it console output. So standard console output, and just bring it over here flashed on the screen. Yeah, so we're just going to remove this. And over here we're going to have, instead of this, we're going to have standard console output, and just put that in the screen. And over here as well, we're going to have standard console output. We're going to have that flashed on the screen. And then we could have something like else, and over here we're going to have standard console output, and we could have the return it's a tie or something, whatever you wanted to add, and we'll put a semicolon. So let's have this printed out. So standard console output, and what the function here is max num. So max underscore num, and what we have here is 3 numbers. So let's give 3 numbers, minus 10, and we have, so minus 10, 0, and we have 10. Say g++ max num .cpp. Ooh, wow, that's a lot of errors. What happened here? Operator, and we have some max num and some issues here. What happened here? Okay, so we have a num over here, num1, num2, num3. If let's see what's the problem here. Let's try to fix it out. So you can see that there is semicolons and everything. What did we miss? So yeah, I understand. A void function would never have a console output. Man, that was a silly mistake, but I make these mistakes all the time, and everyone does. So let's just delete that. So instead of having this over here, let's just delete that. So get this, and make this as 100. And once I make this 100, go back here, and now let's compile this and run it. So we got the 100 because this was the biggest number here. But when we have this reduced and make this as the biggest number, so let's see, go back here, and we get this, compile and run. So we get that as the biggest number. Cool. So suppose that we have that as small and we have this as the biggest number. So this is our biggest number. So go back here, try to compile this and run it. So we don't get anything here. The case here is that we have something wrong with our logic. If this is not true, we go to the next one. And if this is not true, we go to the next one. And num3 is greater than num1. And then we have num3 greater than num2. And these conditions are basically true because both of these conditions apply, because they're both num1, num2, and num3, num2. So over here num1 and now num1. Over here we have num2 and then we have num2. And we have num3 and num3. It should be working. it should be working. And then we have else, we have it's a tie. So for instance, if all the numbers are small, let's say 11, and let's say this has 11, and now let's run the code, and it's gonna have to print out tie. So run the code, and there you go. So let me just go up here, and we have it's a tie. Cool. But the last case here, why is this not showing us the result? It's a mystery. So let me just go back here, CLS, and then run the code, compile and run. So we got the last case as the number that's largest. Cool. It worked here. Now that didn't make sense. Now let's just go and make this as, let's say, 15. If it works now, it should be working. So let's just go here, CLS, and here we have this code, and then we have this. So 15 did appear. So it works, and it's pretty tedious. So let's reduce the amount of lines here, and let's just make it a little more easier to understand and good to see through the eyes. So let's just have all of this junk, which is a lot. Here what we're gonna have is, instead of this like that, let's just reformat this. Okay, so if num1, and we can say and over here. So we're gonna have and statements, and we can say num1 greater than num3. Pretty easy. Now this is what I actually want. So we could have here, we could just return the, or whatever you wanted to standard output. We could just say standard console output, and we could just have that num1. Pretty simple. Here we, instead of that, we could just have else if num2 greater than num1, and then we could just have and, or whatever this and here is, and we could have num2 greater than num3, and then we could have same thing here. So instead of all of that, we're gonna have just delete all that and just leave this over there. So it's just gonna print out num2. And here we have if num3 is greater than num1, and we're gonna have those and we're gonna have num3 greater than num2. Then we can have these removed as well, and remove this, and just get from here. So this, and then we could have else it's a tie. So this is how many lines were reduced because of this format. So just the format we changed, and we reduced the lines of code by making it a little more better, and the same thing is gonna work. So over here, definitely we're not gonna have a tie. We're gonna have that 15 number printed out in our terminal screen. So let's just run the code and verify. So let's just go and say g++ run. Okay, so we have this over here. It says type semicolon before else. So there's a semicolon that's missing, and what looks like I basically turned off my VS Code. Okay, so there was a semicolon missing here, and there you go. We have that semicolon, and now so let's run the code once again, and hopefully we get that number. So we get that 15 number printed out. So that was it with the video. I hope you liked it. If you liked it, go give it a subscribe to the channel. Keep supporting Coding Cleverly. And if you want more videos like this, please let me know in the comment sections. And I will be seeing you guys in the next video. Peace out.